Hello everybody, can you hear me? Headphones on? Awesome, someone nod to tell me they can hear me. Awesome, good afternoon everybody. So I'm going to start with a question. Hands up, did any of you notice an announcement in Dave Brown's session about an outpost, a new generation outpost? Awesome, so what we want to do is we want to spend the next 45 minutes going through what the announcement was, what has been released, where the product's going, and just give you a feel for where Outpost is going. When we finish the session, there is myself and Chris, and there are a few of the Outpost team that will hang around, so if you have any questions, please do ask. Okay, so with that, let's just get started. What we want to cover today is we want to look at the new generation Outpost racks, what they are. We're going to look at what new instance types there are, how we've changed the networking, which is really significant for not just for us, but it's also significant for you. And then Chris is going to talk about some of the use cases. Should have said, my name's Perry Ward, my colleague here is Chris McEverly. We are hybrid specialists looking after Outpost. Once we've looked through that, which will take probably 3/4 of the session, we're going to touch on two new instance types that have never been there before for AWS. Those instance types are called bare metal, and they're the first time we've ever looked at having layer 2 networking out of an outpost to a customer network. So with that in mind, let's deal with the overview to start with. Just a quick reminder, AWS see the cloud as a continuum. At the core of the cloud is the region, and it's always going to be the region. But we recognize that there are use cases that customers need to go beyond the region. We looked initially at launching things like local zones and CloudFront and Wavelength as a metro local extension from the region, so that for workloads that still wanted all the benefits of on-demand utilization, all the benefits of AWS looking after everything, we still had that ability. But then we also recognize that there are certain customers and certain workloads that require AWS services right there, right in their own data centers. And for that, we produced Outpost, and we also have some other services that you may have heard of, like dedicated local zones, EKS Anywhere, and also now EKS Hybrid. So we're going to be diving into Outpost. Now, Outpost is available in more than 75 countries and regions across the globe. That's significantly more locations than regions are available in, and significantly more countries than local zones are available in. This is really about bringing AWS compute through to your environment where it's needed. And I do stress where it's needed, and Chris will touch on that a little bit. But we are looking at 75, and that number has been increasing year on year and will continue to increase. It's particularly being used by certain customers who wanted a fast start to locations that didn't have a region, but we knew there was a region coming. We've got financial services customers like Fab who used Outpost as a quick start before the UAE region was alive. We've got other financial services customers in KSA, Saudi Arabia, who are recognizing that Outpost is a fast start for them to get into the environment before the region is launched. Now, again, a quick show of hands. Have a look at the names up there. I'm sure that you recognize them, and I'm sure that you're looking and saying, I recognize companies like Vodacom, like DXC, like Amazon. These are all companies who are working in spaces that we're working in, and we recognize that there are use cases where really local compute is really significant. Now, what I want to do is I want to pass over to my colleague Chris, who's going to talk a little bit about some of the use cases, and then he's going to drill down into the instance types that have been announced.
Thank you, Perry. There we go, it's all working. So before we dive into what is the new announcements today, I thought it was worthwhile going through where do our customers get benefit today from Outposts. The first use case category we have is data residency, where by bringing the cloud into the customer's colo or into the customer's data center, they can actually use AWS tools and security models to actually have a really compliant, really good posture for their local regulator in the regulated markets. The next one is a new use case we're starting to see a lot of, where customers are finding that they have large databases on premise, or they have large data lakes, and they can't just lift that onto the cloud directly. So, but they do need to refresh the compute and but without refreshing the storage. So by actually putting the Outpost beside the existing storage, it's actually a really good story for the customers. One of the use cases we'll speak a lot about is modernization and migration, where we have a lot of customers today who have mainframes, minis, or really large legacy applications that they can't just take it and move to the cloud in one go. It's too big a lift. By putting AWS Outposts beside that, they can actually take bite-sized chunks out of the monolithic application and move everything piece by piece into Outpost, and then when everything's in Outpost, then they can move the whole thing up onto the cloud while modernizing maybe some of the applications as well. It's a really nice stepping stone for our customers. One of the new use cases we're seeing a lot of is customers where they've realized that they would like the cloud, they want to go all in on the cloud, but they're not able to actually do that because their internal information security departments are saying this data should not leave the building. So by actually putting an Outpost locally to that building, they can keep the data in the building, keep processing that data without any security risk, but still take advantage of the cloud. Perry will talk about the next use case a lot, which is our low latency, because one of the big announcements we've made is a much more lower latency Outpost. And by low latency, we've got customers today who basically are able to deploy Outpost adjacent to their LANs and consistently get 1 millisecond, 2 milliseconds. And Perry will talk about how we go down to microseconds. A really big effort this year and last year for us was VMware migrations. We're seeing a lot of customers who have a legacy VMware environment. They want to move it onto a cloud environment because of all the changes in the market. And we've got templates, design tools, and architectures to actually help you in that journey. So you can move from the existing applications onto AWS Outposts, take advantage of the virtualization, also modernize maybe some of your applications as you're moving across to Kubernetes or containers. And lastly, one of the things that we talk a lot about is generative AI. The joke we were having earlier is that everybody has to have generative AI on everything. In AWS Outposts, what we've actually managed to do is help our customers that want to run in regulated markets where they can't use the cloud because the regulator is saying don't move your data out of the country or the data center. And we're helping the customers run small language models really efficiently at the edge. And we've templates for designing and optimizing those SLMs and giving you a choice of SLMs. So again, really good use case for Outpost. Switching gears to the next slide is Gartner produced this report last year in October for distributed hybrid infrastructure, which is a bit of a mouthful, but it basically means allowing you to run cloud security models and everything else where you want to, on your colo, in your data center. And in that report, they've actually awarded or ranked AWS #1 in 4 of the categories. Hybrid infrastructure management is basically extending the cloud into your data center and managing it with a consistent set of APIs, which Outpost does. Edge computing is fairly obvious, it's running at the edge. Assured workloads is different. It's actually data residency. It's basically being able to prove that your data is sitting in the colo where it's supposed to, having the tools to show compliance to the regulator and having the tools to actually protect that data so everything's, for instance, stored encrypted. And AWS does a really nice job of that, of taking the security posture we have in the cloud and giving it to you in your data center. And lastly, they said that our AI, generative AI and machine learning tools at the edge are one of the leading in the markets. So you can run ML, you can process data locally and get really we've use cases that basically need really low latency between the ML model and, say, a robot or something for health and safety is one example of a use case there. So one of the big announcements we announced yesterday, and we announced today in Dave Brown's presentation, is a second generation Outpost, which is a new Outpost form factor in that it comes with 2 racks now, a networking rack and a compute rack. And importantly, the scalability of the racks are much higher. The racks come up to 30 kVA rather than 15, and with that extra power, we can put a lot more compute instances in the rack. The first generation rack is still maintained and sold, and we're actually delivering that for customers that want, say, smaller form factors or don't need they need some of the features that are not yet available in the Gen 2 rack. And we're still selling the AWS servers, which are a 1U Intel Graviton server and a 2U Intel server for locations that don't have the space for putting in a rack or just need 1 or 2 vCPUs at the edge, but still want to run everything as if it's running from the AWS cloud. So in this second generation Outpost racks, the first thing we've done is basically made it more performant in that you can have a denser packing of servers in the rack because the network components are moved to a separate rack. It actually can scale much higher in terms of vCPUs per rack, and the performance of those vCPUs is the current generation 7i instances. One of the important things we've done is by taking the networking out of the single rack and making it a separate rack, we now can scale the networking much higher and also have it more resilient than if it was all in one rack. So we're actually changing the way the Outpost racks scale, in that you can scale the network up to much higher numbers without having to add extra servers in, which was the case with the Gen 1 rack. And lastly, we have a range of ultra-low latency bare metal instances that give really high throughput per server or per network interface card, and that allow you to do ultra-low latency workloads that require microsecond rather than millisecond type latencies. So just to reiterate, the Generation 1 Outpost will still be sold, and it will still come with MC or instances. And we also have a GPU instance, and the storage is i3EN. This Outpost will still continue to be sold and supported, and it does have a role to play in areas where you may not want to have 2 racks, or for cost issues where a colo is charging per rack location. One rack solution may be a better option here. But going on to the Gen 2 racks, firstly, the overall performance increases by up to 40% compared to the Gen 1 rack. And we're using the latest Intel Xeon Sapphire Rapids processors, so it's a much more performance CPU, and they're available in MC or R instance types. We will have a range of GPUs coming soon, but they're not available today. And we have bare metal instances that my colleague Perry will talk about shortly. And we also have EBS block storage in that rack as well. So then comparing the two together, the first generation rack basically has a balance of performance and efficiency in that everything is sort of grows together, like you get more network capacity as you add more servers. You have MCNR and G4DN instance types, and it's linearly scaling in that you add more compute, you get more networking capability. Whereas the Gen 2 rack, basically, by splitting the network and the compute racks, you can actually scale one or the other without having the linkage we had in the Gen 1 racks. And it also gives you the latest compute innovations we have in the M7 range, or CNR7 range. And you notice the 2 names there that we'll talk about later on, which is the bare metal instances. And by decoupling the compute and storage and networking, it scales better. Both racks will support static stability, which we'll launch at reInvent. And but that means if the connection to the region goes down, the rack workloads will continue to run in a static mode, and also we have a satellite backup for the service link, so if the internet goes down, you can still jump over onto a satellite and continue to use the racks. And the main difference is the power, which is the Gen 1 racks go 5, 10 or 15 kVA, and the Gen 2 racks are 10, 15 or 30 kVA. And that 30 kVA allows you to be much more dense on the packing of your compute. In terms of features, both racks support EC2 instances, both racks offer EBS storage, and VPC cloud computing and all the other bits with NACLs, security groups, etc. all work same as they did before. Direct Connect works an application load balancer. Then the Gen 1 rack has S3 local snapshots and Route 53 resolver, whereas they're not available in the Gen 2 rack. Both racks support CloudFormation, Terraform if you like Terraform, CloudWatch, CloudTrail, so all the APIs are the same. And once you have the rack up and running, it is on your console and it looks like another AZ. So the user experience once it's running is very consistent. Looking at the services we support at launch, ECS, Container Service, Kubernetes, RDS and EMR, and Greengrass, IoT Greengrass is supported in both Gen 1 and Gen 2, and then Elasticache and disaster recovery are supported in the Gen 1 rack. We will be announcing more services over time, and one of the things I would ask you to do is contribute feedback to us saying, I need these services in the rack, because if you don't give us the signal, we won't know what to build for you. Okay, I'll hand back.
Thanks very much, Chris. So my personal geek space is networking, so I wanted to really just touch on what has changed about this rack and why it matters to you. So Chris mentioned we're now at a 2-rack basis in the next generation Outpost. Everything is based around a single networking rack or a networking rack and then multiple compute racks. So we've always said in Outpost that the Outpost instances are the same as they are in region, but as we've gone through newer generations of hardware in region, we've wanted to be able to make those changes just automatically come to Outpost. And we've done this through deploying a separate networking and compute rack. Every customer will now get deployed for next generation Outpost a networking rack, and then we can add compute racks onto that networking rack so that we're abstracting that compute and networking apart. So that gives us a few things. The networking rack firstly contains a whole core network environment. Now for those customers who previously bought Outposts, they're probably used to the idea that we would say 1, 2, 3, 4 racks, no consolidated or aggregation layer needed, but once we start getting up above 4 racks, it's good to have an aggregation layer in there. But our customers said to us, this is a problem. It's partly a problem because it means we're having to connect many racks, many compute racks to our environment, so it's eating up our own ports. And it's partly a problem because if we don't know if we're going beyond 4 racks or not, then how do we know if we need an aggregation layer or not? So we said, okay, start with a highly resilient multiple switch aggregation architecture. That then means that we can add compute racks. In our parlance, in our language, a compute rack is either compute or storage. Every compute rack has a top of rack switch, and then those compute racks will at minimum contain some EBS, so you've got some storage. In fact, it's worth knowing that some of the architecture, things like Nitrous Security Key, some of the top of rack architecture has gone from AWS Outposts back into the region and is now feeding some of the designs that work in region. So this is that consistency between Outpost and region. There is no difference. And then what happened there? Button didn't work. Then once we've got the compute and the networking, well, we have to connect it out to the world. And that requires what we're calling network compute, which is all of the processing capability to be able to connect both service link back to the region and local gateway out to the customer. Now, something we've had previously with Outpost is the throughput the performance of the networking was very much tied to the number of physical hosts that were sitting in the Outpost rack, simply because as we added physical hosts, that was where the networking compute was residing, on cards inside those physical hosts. Now we've separated out that architecture. From day one, the throughput of the environment is at that maximum throughput, even if you've only got a small amount of compute in your environment. And then you add compute, M, C, R, and all of that compute, as Chris said, comes from the new Intel Xeon Sapphire Rapids environment. So it's the next generation of compute hardware. Now, just touching on that again, what do I mean by scalability? Well, we are starting with one networking rack that everybody gets, and that one networking rack can now support up to 24 compute racks before we need to expand that networking rack to be a pair of networking racks. And that expansion requirement is really about port count and port density. It's not about throughput. So we're really now significantly more expandable than the original Generation 1 Outpost. We can go to 24 on one network rack and way, way beyond that. We're designing this also to be simple. Expansion of hardware in a data center always bears risk with it, that if you're starting to plug new cables into switches, you're starting to add hardware, what's the risk of interrupting something on the existing hardware? So by having this core networking rack that we don't have to start fiddling between compute racks, we're lowering further the risk of any failure during a maintenance window as we're expanding the Outpost. So just to remind you, the Outpost, this is physical networking. The architecture of Outpost in terms of VPC networking has not changed. It's the same as it always was. The Outpost is an extension of the VPC in region. The subnets in Outpost are just additional subnets within that VPC, just as if it were perhaps another AZ. The interfaces in region, the VPC endpoint, the transit gateway, the peering, all of the services that you can access in region are still accessible through endpoints, still accessible just the way you did with Outpost. Even internet gateways still accessible through Outpost. And the component that sits within the Outpost, the local gateway, is the component that has now effectively been improved for performance and improved for throughput. What I'd like to do is I'd like to ask Chris to just talk us through 2 or 3 specific use cases so that we can then go on and after that talk about the bare metal instances.
Yeah, so we thought it was worthwhile diving a little bit deeper into 3 sets of use cases. The first one are the migration and modernization use cases where, and these are broke down into 3 subcategories. The first one is VMware migration, where we have a set of tools, design templates that allow you to easily move your VMware workloads onto the AWS Outpost rack. Customers have already given us good feedback in terms of TCO, and the operational model of the Outpost actually eases a lot of their internal concerns that they have today. And it also improves the scalability, because I'm not sure if you're familiar with AWS Nitro architecture, but it's a secure environment in the server. It's not like just running a VM on a server. We actually secure the server for you. We store everything encrypted, and all the communications between the EC2 instances are encrypted as well using the Nitro architecture. So it's a much more secure environment. And by consolidating everything on the Outpost rack, customers can actually remove themselves from certain data centers, have a smaller footprint in a colo. And what we got real feedback with customers is that by moving onto AWS Outposts, where AWS do the undifferentiated heavy lifting of the management of the racks, etc., they've actually improved their IT productivity and improved their overall delivery of services. So it's not just replacing something that gives a better TCO, it's actually giving a whole different profile to the way you actually manage IT infrastructure. Then the other use case we've seen a lot of is IT infrastructure. I've had one customer where for one database query, they actually made 125 queries into the database to fill one form in. And that was fine as long as they're all co-resident. But when they tried to move the application into the region, and even though the region was less than 10 milliseconds away, it was now 10 milliseconds times 125, and they were actually had customers come back and say, you're filling my form in way too slow. So what they've now done is gone back and put an Outpost rack beside their mainframe, having a 1 millisecond latency between the two, so that the 125 queries doesn't really matter. And more importantly, they can modernize the application bit by bit, move it onto AWS Outpost, and the plan they're now doing is they move a whole workload onto Outpost and they move it up to the region and it all behaves properly. So that's a really good use case. And that's also where we talk about a two-step migration, where basically customers move from their legacy setup into the AWS Outpost, get everything modernized, and then move it up to the regions. We have a lot of customers that are actually doing that, and they talk about like 2 and 3 year migration programs where they move off a mainframe into Outpost and then up to the region. So it's a really nice template. The other use case we have is data residency, and the key thing here is it's not the traditional model of run everything on a server in a colo in a region as data residency. With AWS, we've actually changed that definition a bit, where we wrap a security wrapper around the system. We basically have a set of policies that means that you control via policies where your data sits, how it's processed, who can access it, which gives a much better profile for your compliance report. And the last one we do is we actually have compliance reporting, where you can actually send reports to your regulator saying, look, I can prove exactly what's happening with your data. It's staying within the country, the region that it needs to be in. The AWS shared responsibility model means that we look after the hardware infrastructure in the AWS Outpost, and you run your applications on top. And there's no path from AWS operators connecting to the infrastructure into your applications or data. So again, we have reports that we can share with you for regulatory approval, where it really is a secure environment. And by actually adding in the extra security tools we have, like the encryption, your personal certificates used to encrypt everything, and the stateful firewalls, etc., that we have inside the Outpost, that actually gives a much higher level of confidence with the regulator than just running something on a server in a colo. And the last use case I was going to talk about is generative AI. So we see a change in the market, or the market's splitting, I guess you could say, where a lot of our customers are in regulated markets are telling us that they don't want to run LLMs locally. They want to run SLMs and have an SLM address each specific task that they're doing or use case they're doing. And by using Outposts, we can actually deploy SLMs locally. And we don't recommend one SLM. We actually give you a toolkit where you can choose up to 55 different SLMs, run them locally, and you can either run them from the AWS tools in the region, where you're using SageMaker and Bedrock and deploying the models locally, or in the case of some customers, they want to actually run the model completely on-premise, and they want to own the model, own the code, have no data going back to the region, and therefore they want to run their own self-managed models. We support that as well. And the model approach we're taking is basically to have SLMs, support fine-tuning, support RAG, and prompt engineering locally, which gives you a very nice toolkit to run a model with a few GPUs rather than having a big farm of GPUs. And these actually do address the InfoSec. We've had a number of customers come to us saying we don't want to train our model in the region with data. We want everything to stay on-premise, and this solution seems to resonate very well with these customers. I'll now hand back to Perry.
Thanks, Chris. So I'd like to spend the last 15 minutes talking about the bare metal instances, the accelerated networking instances that we've launched today. And as I said, this is the first time that we've had rack, Outpost rack, capable of layer 2 connectivity. So understanding the different instances. The first one I want to talk about is the BMN SF2E. So bare metal, why we're talking about bare metal is that these are instances that you get access to the server, not a virtualization plane. So why did we create them? Well, customers were saying to us that we need low latency and deterministic networking capability, and that's down to the microsecond or down to the tens of hundreds of nanoseconds, that the milliseconds or sub-millisecond latency of traffic being routed through a routed connection into their network simply wasn't low enough for especially financial markets where that access to really super accurate timing is important. Also, we needed the ability to support multicast, which is something that, although we can support multicast in region through use of the transit gateway, it's not native multicast. It's not being able to connect to a layer 2 network and be able to receive multicast, and that we did need specific dedicated layer 2 networking. Whilst the Nitro card is an amazing piece of technology, and if you're not familiar with it, I'd encourage you to go and read on our website about the Nitro card. There are requirements within the financial services industry and others where super high performance, low latency networking is required, and where the networking stack is entirely offloaded onto cards. So we listened to our customers and we realized that this was also a gap that we had in our story. We needed to fill the gap, which was trading locations. Now, we did start that conversation and that story 2-3 years ago when we talked about NASDAQ and what NASDAQ were doing with 3 of their markets, and I'll touch on that later. But we did need to fill that story, not for a specific customer, but we needed to fill that story for our customers, plural, who wanted something at trading locations. And that was typically in a customer's own data center where they needed fair and equitable access down to the microsecond or nanosecond. And do remember, 1 meter of optical fiber is a 5 nanosecond latency. So you go and give somebody 1 meter or 10 meters and you're creating a 10x difference in latency. That's 10x, and that is really significant when you're talking at the microsecond or nanosecond layer. So we already had the ability, and we announced with the New York local zone, we had the ability to do trading support for things like streaming of prices near to exchanges, and we already had the ability in region to do end-of-day clearing, to be able to do repo clear, things like this. We didn't have the ability to do in-exchange capabilities. So this is what we've added with the bare metal. And I do want to just sort of pick out, sorry, I just need to go back to pick out 2 statements. NASDAQ say to us that they've now implemented bare metal instances within 3 of their markets. Those instances are handling 36 billion messages a day. So just get that number again, 36 billion messages a day. And they're seeing a 10% drop in latency from their previous solution. Now, 10% might not seem much, but I think if you talk to algo trading businesses and quant environments, 10% is really significant in that environment. That's a quote from NASDAQ. I'd also like to attribute a quote to a customer of ours who made a big announcement yesterday of signing a new 5-year agreement with us, and that's London Stock Exchange. And London Stock Exchange are looking at the bare metal instances to build and support low latency trading within their environments as well. So let's actually drive into what that bare metal instance is. It's ultra low latency. It's making use of solar flare, so that's AMD solar flare networking cards, which are very commonly used in the trading industry, and those cards can provide super low latency straight into a piece of hardware, and that hardware can then be tuned by the customer to give it the best performance possible. The deterministic networking nature of these low latency cards means that they can also support things like extremely accurate time protocols, and they can support multicast. And I know I keep saying multicast, but this is a massive thing for the exchange trading environment. But they can also give the customer a consistent look and feel to what they're doing in region. So they're not having to deploy an environment that is completely different in region than they are within data center. So that physical component, this slide looks incredibly similar to the other slides. It has exactly the same networking component, exactly the same compute component, but the difference here is that the compute component, the compute racks, have bare metal top of rack switches as well, not just VPC top of rack switches. And those bare metal top of rack switches have equal path to every single server, so we can give fair and equitable access to all. It also has the option of EBS, but we're not shipping by default with EBS because many of our customers are telling us that what they want is local disk. So EBS is an optional rather than a default. And each one of those physical servers, just to be clear, those are latest Intel Xeon Sapphire Rapids servers, 120, well, not 128 vCPU, because in bare metal, we're talking about cores. So 64 cores, 1 terabyte of memory, Nitro cards so that it can carry on doing all of the capabilities that VPC networking gives it. But in addition to that, a SolarFlare card, in fact, a pair of SolarFlare cards. Each of those cards have 4 times 25 gig interfaces. So that is capable of 200 gig, which is, I would say, 200 gig per server is significantly higher throughput than we've seen previously with the first generation of Outpost from an entire rack, or being able to drive 200 gig per server from an entire rack wasn't possible before. How does that fit with the AWS architecture? Well, these servers are now dual homed. So these servers all have an ENI, just like you're used to in AWS. That ENI is capable of supporting VPC, subnet, security groups, ACLs, all the stuff you expect from an ENI. But in addition to that ENI, those servers are dual homed to an LNI, a local network interface, and that is specifically for a low latency, high performance trading network, which can run alongside the rest of the network. Well, that's one of the offerings, but I said one. The second one is the BMN CX2. So bare metal, CX2, because it's got a slightly different networking card. So this was announced actually in Mobile World Congress in Barcelona back in March. Yeah. I feel March, but let's drive some more details. This was announced there because it's useful for telco, but it's useful for telco, it's useful for media, and it's useful for any other environment that is doing super low latency, but also super high throughput. So I sort of want to say, what's super high throughput? I thought we've already talked about high throughput. Well, this is faster. So the networking architecture of this looks very similar. A networking cabinet, a compute cabinet. A compute cabinet contains bare metal top of rack switches as well as standard VPC top of rack switches. And a compute cabinet can also contain EBS, but it doesn't have to, because again, customers are telling us that often what they want in these environments are local data storage, not EBS, simply because local data storage has that ability, just like local data storage, instant storage in region, to get slightly faster throughput. So what's this instance? This instance is based around Intel Sapphire Rapids, latest generation Xeon. This time we're talking about a 96 core. So that's what we think of as 192 vCPU. but a 96-core processor with 1.5 terabytes of memory. And this time what we've put in it is NVIDIA Mellanox cards. And those ConnectX-7 cards have 2 ports each, and each port by default has 100 gig SFP, so that's 400 gig. But we are able to put 200 gig SFPs in there as well, so that's able per server to drive 800 gig. That's 800 gig of traffic, hence more processor cores, because you need that many processor cores to drive that level of traffic. Again, we still have Nitro in there. Again, we still have VPC networking. We're separating out a layer 2 network for super high throughput and a VPC network for stuff, and that's a really technical term, stuff to go back to region. In addition to that, there are some enhancements that we've been able to work with the EKS team to support other CNI capabilities. So often these CNIs are supported by a third party, but we're able to use EKS on this environment to be able to use things like the Multus CNI, to be able to do VLAN tagging for specific container workloads that want to talk through this high performance interface. We're able to use SRIOV from the native drivers for the CNI from Mellanox to be able to drive throughput. And we've still got the VPC CNI, so containers can choose what they're talking to. You can launch a container, and that container can be using VPC CNI to talk to other containers in the environment or back to region, or it can be using something like Multus to talk through the physical instance for the physical Ethernet port out into the high performance network. So, a summary, because that's a really whistle-stop tour of what the new announcements are. Networking rack. I really love the networking rack. You get the idea. Networking rack gives greater scalability, starting with that scalability all the way up to 24 compute racks. And remember what Chris said, each compute rack is also capable already of higher density. Higher throughput on day one. You have all the networking on day one. You're not looking to build up the network compute layers as you add more components. New instance families with a 40% improvement in performance, and new instance families including the bare metal instances for layer 2. Now, what do we need from you? We need 2 things from you. The first thing is we need you to tell us what else this environment needs. We've built an environment now that is way more flexible, but now we need you, the customer, to tell us what's wrong with this, what else you need from this, and how we can improve it further. Because everything we've done with this next generation has been on the back of some key customers who've given us that feedback. But we want you to come and talk to us after this session, and come and talk to us after this summit and tell us what else we can do. The other thing we want from you is please to scan the code. Don't worry about 1, 2, 3, or 4. You only need to click 5 as the feedback. Just scan the code and give us feedback, because the way we know if we're doing the right thing in these sessions is if you're giving us the feedback to tell us how we've done. So thank you very much, everybody. Thank you, Chris. And if you do want to talk to us, please come to us afterwards.